This is the continuation of rectifier. Second type of symbol rectifier circuit. It's known as full wave rectifier. As the name suggests, both half cycles of the input AC is converted into DC. We follow the same route, principle, circuit diagram, the waveforms and the working. The basic principle remains the same. PN junction diode conducts only when it is forward biased. In reverse biased, it does not conduct provided the voltage don't exceed the breakdown voltage. Circuit diagram is slightly different from half wave rectifier. Normal transformers, we have two terminal output, but here there's a three terminal output transformer. It's called sender tap transformer. There's an additional terminal from the sender. It's a three terminal output transformer. Other than the two terminals, this is terminal from the center. The top and bottom, the end terminals are connected to two diodes, P region, and the sender tap is connected to the load resistor. All the three are together connected to one particular point, the end regions of both the diodes and the load resistor. The number of turns of the secondary actually has to be less compared to the primary because it's step down transformer. AC is applied in the input of the primary. Input means primary of the transformer. It's a circuit diagram. So this one better to have more number of turns and less number of turns in the output. Two terminals X and Y just for specifying the direction of current. Now we check the input and output waveforms. The first graph represents voltage at A. So whenever A is positive, B will be negative. Alternately, A becomes negative and next B becomes positive. So this is a voltage at A, positive, same time B is negative. Now A becomes negative, B becomes positive. So it's alternating in terms of the polarity direction. Like the previous case, whenever voltage at A is positive with respect to the sender tap, the D1 is forward biased because A is connected to the positive terminal is connected to the P region. So it becomes forward biased, conducts current flow from A, D1 through the load resistor from X to Y and through the center tap. Same time, A is positive, B will be negative. So diode 2 is connected with negative to B, low potential to P, it's reverse biased, does not conduct. So no output from D2. Now, next instant, the next half cycle, A becomes negative. A becomes negative, D1, P region connected to negative, low potential. It becomes reverse biased and does not conduct. So no output through D1. At same time, we have B becoming positive. So the P region of D2 is connected to positive high potential. This become D2 become forward biased. Current flows from B, D2, again through the load X to Y in the same direction. That's important. Current flows in the same direction. In a half-wave rectifier, the current was absent for the second half cycle. So by making suitable arrangement with a special transformer, two diodes, connecting the resistor and diode common to one terminal, we can get current through the load resistor in both the half cycles in the same direction. So the output is in the same direction all the time, X to Y, but still it is pulsating and pulsating. It's continuous. Last case it was half-wave rectifier case, it was discontinuous. So whenever A is conducting, the output due to D1. Next time B is conducting, the output is due to D2. So this process is repeated. We get a continuous but pulsating unidirectional output across the load resistor. The efficiency of full wave rectifier is double that of the half wave because both half cycles are used. Only issues, the output is pulsating, and we have a special type of transformer needed for this particular type of full wave rectifier.